So good morning or good afternoon, wherever you are in the world watching this, and welcome to this kind of masterclass on looking at how we can use the calendar risks within Safran Risk to I guess to build up models that are hopefully just a little bit more realistic. And I guess what we're going to be looking at is really kind of how we can look at risks in Safran where the probability changes over time. And I'm a kind of a big believer in this idea that when we're building up our probabilistic models, we're really trying to make models as realistic as possible about what might happen in the future, so that we can kind of make better decisions in the present day. And understanding how to use probabilistic risk calendars is, I think, a really fundamental part of that. So I'm kind of quite excited to be sharing some thoughts and some ideas with you, for particularly for those people who've never seen this working before. So just really quickly, in terms of a very quick introduction. Oops, too quick, just slid through the slides. Ferryfield have been working with Safran for almost 5 years now. We're one of their kind of premium partners. We deliver a lot of the training courses on their behalf, the certification training, etc. And so we're a bunch of people who have all been working in QRA for 15-20 years in some cases. And so we thought it'd be quite a good idea just to put together a little webinar on calendars, because actually during the training courses, it's often one of the most surprising things for people who haven't seen how this works before. It's always a point of real interest to people who attend training courses that we deliver. And so we thought it was worth just putting together a little session to give some more details on that, and to show people exactly how it works. So that's it for the PowerPoint. I'm really not a big fan of PowerPoint, so what I'm going to do, I'm going to hop out of there. I'm going to jump into the software and kind of explain a little bit more about how it all works. One thing I am going to do, actually, I appreciate that some of you might be kind of in kind of places where the internet access isn't quite as fast, and so just to kind of save a bit of bandwidth, and also so I don't have to worry about what my facial expressions are doing, I'm just going to turn off my camera very quickly, so as not to be a distraction, and then you can all focus on the software rather than my face. All right, so hopefully everyone on the call has kind of had some prior experience of Safran at least, but for those of you who haven't, very quickly, it's a tool for doing project risk analysis. How it works is that we can import our schedules from Primavera, we can import our cost models, and ultimately we can import our risk registers to then run a quantitative risk analysis on our projects. So I'll kind of touch on a few different pieces of the software as we go through naturally anyway. But really the starting point, I guess, is going to be, I'll give a kind of very quick introduction about the model itself, which we're going to be looking at. And then we're going to see how probabilistic risks, probabilistic risk calendars can really kind of play into a different type of modeling. So as just by very quick way of introduction, what we've got is a very simple schedule that's been imported from P6. We've got something like 35 tasks in it. Very small schedule. And some of these tasks are they're all grouped into different phases, and ultimately what it is, it's a project where what we're looking to do is to build a drone, an unmanned aerial reconnaissance vehicle, which is this kind of UAV prototype. And actually it's a slightly kind of adapted version of one of the example models that comes with installed, or you can install it with when you first run the Safran install. So it's one of the Safran example models. And so what we've actually got, we've got a couple of activities down here, this test guidance and test GPS systems, where that's the point where we've done all the kind of the manufacturing and fabrication work, and we finally got to the point where our drone is going to get up in the air and hopefully do some testing to see how it all works. But actually, much like kind of flying a kite in high wind speed, I guess that if the wind speed is too high to fly a drone, then that can cause problems and maybe cause it to crash to the ground. And so what we've in our Safran project risk register over here, and we've got a whole lot of different risks, etc. But this one down the bottom is this weather downtime risk. And so what this is, the idea here is that if the wind speed is greater than 15 meters per second, then that means that we can't, that we can't really do our testing. But what we can see is that actually the probability of that wind speed, it varies over the course of the year. And so we're gonna do this slightly backwards. We're gonna first of all we're gonna see what the impact of these probabilistic risk calendars is, and then after that we're gonna look at how to build them. So I'm gonna kind of explain a little bit about how it works from the perspective of the results, and then we're gonna kind of take a few steps backwards and actually go and see how we go about building them up. So what we've got a project risk down here where if the wind speed is greater than 15 meters per second, that means that we're not going to be able to do these two activities which we've mapped this particular risk to. And what you can see from this high level kind of schematic as to the average downtime probabilities on a month by month basis, what you can see is that if those activities are happening between the months of kind of April and September, then there's something between a 1 and 6% chance that the wind speed is going to be too high, and then that's going to mean that those activities can't proceed as planned. But if those activities are happening between the months of October and March, you can see that there's a much higher chance that we're going to get some downtime because of this high wind speed. And so, again, we'll look at how these get created in a little while. But whenever we want to start bringing these in, we create a new project risk in the way that we would do normally within Safran, and then when we select this calendar risk type down here, this kind of window on the right hand side, it looks quite different to the normal window, which is when we create a new risk, we get to choose our schedule impact, we get to choose our cost impact, and everything. It's got this kind of very standardized look and feel to this window on the right hand side, but the weather one, it looks very different, and the idea here is it just kind of gives you a bit of an idea as to what the likelihood is of a particular risk for a particular period of time. So the whole kind of purpose of actually working with these is that when we're working in a deterministic world where our schedule is kind of fixed in stone, we kind of, the planner was created in P6, and because it's a deterministic calendar, because it's all a deterministic schedule rather, because there's just kind of one particular scenario which we're creating in P6. What we can see is that we've got this testing of guidance starts at the kind of towards the end of September, and then the GPS systems finishes at the start of November. And so when our kind of calendar or our activities are set in stone, which is the kind of the implication of building them up in P6, then we might be able to say, and it'll be kind of incorrect to do so, which I'll explain a bit more about in a moment, but we might be able to say that, look, between kind of the months of pretty much we're doing this in October, this activities, these two activities, end of September to the start of November. So if we go and have a little look, we can see that maybe, broadly speaking, that's in October. So what we're going to do is we're going to add 29% onto those two activities to account for this high wind speed. But of course, as soon as we start moving into this probabilistic world where instead of this idealized version of a schedule that we've created in P6, a deterministic schedule where there's only kind of one time period where these activities are actually taking place, as soon as we start moving into a probabilistic world where our calendars start to move around, our activities are all starting to take place at different times, you can see that the time period when these activities are taking place is actually no longer set in stone. So although sometimes the activities are taking place in October, November, they're also taking place in August, they're also taking place in January, etc. So depending on what's happened beforehand, the time period where we're actually seeing these activities occurring is itself a moving target. And so simply just adding on a certain amount of time according to when we thought the activities was going to take place is potentially quite a dangerous way of doing things, because if those activities take place a lot later, maybe we've had some kind of delays to the project and the activities have been pushed out, then what we could potentially be doing is adding on unnecessary time that we didn't need to. Likewise, maybe we've realized some opportunities, or we've changed the way in which we're managing the project, and actually rather than them taking place in September and October time, maybe they're taking place earlier in the year, in which case, once again, maybe we don't need to add on that contingency. And so the whole kind of idea here is that we want to make sure that whenever the activities are simulated as taking place when we run a simulation, we also want to make sure that we're generating and we're capturing the impact of this kind of probabilistic downtime, this downtime which is itself uncertain. So if I just let me just finish this the simulation off here quickly. And Gustavo, if you wouldn't mind, if you could just make sure you kind of admit people as they come in, because I keep getting little windows popping up on the screen. So if you wouldn't mind just kind of clicking to admit people, that'd be very much appreciated. Um, so so I've just kind of run a simulation, and of course, what we can see from here is that although when the activities were supposed to be taking place looks like it's kind of reasonably set in stone when we're doing it deterministically, as soon as we start moving into a probabilistic world, actually we can see that the actual, the completion date for these activities, there's quite a bit of variability around them. So in this particular view here, what we're looking at, we're also capturing the P50, P80, and P90 finish dates for activities as well, and so we're kind of representing those things on the graph. And so the idea here is that we don't know exactly when when those activities are going to happen. So we want to make sure that the amount of time that we're adding on is something which is realistic. So let's go and have an actual kind of look at the calendar itself. So if I go into my risk calendars one here, and incidentally, for those of you who are kind of new to Safran or have got a trial version or kind of like even long-time users of Safran, if you don't see this risk calendars tab up here, the way to kind of make sure it's visible is just to click on this little thing up here called the burger menu, go to options, and then make sure that your risk calendars tab is checked so it's visible. So the global risks and the risk calendars are hidden by default. So if you don't see them, just make sure you go and uncheck them up here. So we're going to have a look at the actual wind speed calendar within here. So this is the Safran risk view on a probabilistic calendar that's been set up. And so what we're seeing here is at the moment we're in this all samples view, and you can see that this wind speed calendar runs from the 1st of January 2025 to the 6th of January 2035. And if I scroll across to the right hand side a little bit, what you're seeing on these numbers on the screen for each of these calendar dates, what you're seeing is the average probability of downtime on a given day. And so what you can see here is a kind of almost like a zoomed in version of the numbers that we see on the project risk tab here. But rather than looking on them on a monthly basis, here what we're doing is looking at them on a daily basis. And of course we could, if we wanted to, we could zoom out or zoom in if we particularly needed to. But what you can see then is that between the months of October through to the end of March, we've got a much higher probability of downtime than from April through to September. So, of course, if the activities are going to be happening between October and March, we would expect there to be a higher chance that the completion date of those activities is going to be affected by this high wind speed than if those activities were happening earlier on in the year. Now, this particular view here, it's quite a kind of, it's an interesting one to kind of understand how it works, because what we're seeing on the screen is for any given day, we're seeing the average chance that we're going to get downtime from that high wind speed that we've just been talking about. But of course, when we're using a tool like Safran, when we're talking about probabilistic modeling, the average downtime, this kind of concept of the average or the expected value, isn't really something which is particularly kind of not particularly useful or exciting, because actually what we're really looking to understand when we run a simulation is the event happening, yes or no? Is the wind speed too high, or is it low enough that it's okay for us? And so those are our kind of two different scenarios that we're really looking to model. And so although this shows us the expected or the average value or the average chance of downtime on any given day, if I move from this all samples view to go into the Monte Carlo view, I call it, this kind of iteration by iteration view, what we can then start to see is we can see the samples which have been generated by Safran and which are then applied during a simulation. So iteration number 1, this is what my calendar downtime looks like. Iteration number 2, this is what it looks like. this is what it looks like in iteration number 3, and so on. So each of these samples that we're seeing, it represents one possible outcome. And we've just created 100 different kind of possible outcomes. So when we run a simulation, iteration number 1, we're going to see this set of downtime. Iteration number 101, we're going to see exactly the same, 201, and so on. So Safran kind of just cycles through it. You reuses once it's got to the end of the samples, it then goes back to the start and begins again. And so what we're seeing is the iteration by iteration downtime for any given day. And so essentially what Safran's doing with these is it's creating additional non-working periods, and then it's applying them to our regular activity calendars. And so if an activity, in this case our guidance and GPS systems are happening on a day where there's downtime, then the completion date gets pushed back by a day, because we've had downtime simulated, we've had this additional non-working period that's been added in, and so the completion date, the end date for that activity, it gets pushed back a day. Oops, sorry, wrong place. And so how these work then, so whatever activity calendars our planner has set up, so for whatever activities we've got down here, the GPS systems and the calendar, whatever activities, so whatever calendar type we've got that our planner has set up in P6, in this case it's my standard calendar, which is this one over here. The standard calendar, it's a 7.5 hour day, and it's 7 days a week, so we haven't got any non-working periods in here already. And so each day of downtime that we're adding from the calendar it always counts, if you like. Whereas if we had any non-working periods, then if that day of downtime was simulated as occurring on a non-working period anyway, then it wouldn't have any effect. So the way this works is these calendars, they work in conjunction with the existing activity calendars. So however they've been set up in P6 by the planner who built the schedule originally, these get kind of added to it. So for example, let's imagine that our activity is due to start on the 1st of January, and it's a 10-day activity. So in this particular iteration here, the activity starts on the 1st of January, and we haven't got any non-working periods, and so it will start here and then it'll finish over here somewhere. This next iteration, this one here, we can't start it until the 6th, so we do a couple of days here, and then we have another whole load of downtime, and so then we'd actually finish this particular in this particular iteration maybe sometime around the 22nd. This next iteration, we have 4 days of downtime at the start, and so then we're gonna be finishing sometime around the 14th or 15th. And so if we had additional kind of non-working periods in here, for example, let's say we had non-working period for Saturday and Sunday in the activity calendar, then all we'd have in this particular iteration was 2 days of downtime, because these 2 days here are non-working periods anyway, and so Safran it applies the probabilistic calendar it works with however the original activity calendar has been set up. So let's kind of just run an analysis and generate some results, and kind of let's see how this actually plays out then. So what we've got, we've run our model, we've looked at the overall finish date of the project, and within that we had all these different risks and uncertainties being applied, and we've got this weather downtime risk down here. And so what we can actually do, if we go and have a look at the sensitivity analysis tab in Safran, what we're able to do is to actually compare and see exactly what the impact of each of these different risks were in the risk register. And so if I go to sensitivity analysis and click calculate impacts, then what Safran's doing, it's what's known as a sensitivity analysis by exclusion. And the idea here is that Safran it runs a simulation, and then it takes out each of the different risks in the risk register one by one, and then it compares and it calculates the delta, the difference between the risk being in our results and the risk being taken out of our results. And so what we're seeing up here is that within this particular model, the difference between that weather downtime being in our results and being taken out of our results equates to 20 days of difference. And it equates to 20 days of difference at my P90. So I could choose a different percentile that I'm particularly interested in. But that's the amount of impact at my P90. So if you imagine going and having a look at the results, and in one P90, we've got a finish date here. Then if we then took that out, that P90 would change. And what Safran's doing, it's comparing the difference between those two things. And so actually, I'll go and just kind of explain that in a bit more detail. What I'm going to do, I'm going to turn everything off here. I'm just going to have that weather downtime and none. And the idea here is that what we're doing, we're basically comparing two scenarios. And so the difference between having that weather downtime risk in my model and being taken out of my model is equivalent to 20 days. And if I go and have a look at that on the S-curve view, what we can see is we can see those two different S-curves. So the black one is the one where that weather downtime risk hasn't occurred. Has occurred. And then the red one is the one where it's been removed. And the difference between these 2 points at my P90, which is this kind of point on the S-curves here, is equivalent to 20 days. At my P80, it's only 16 days. So what I'm seeing is that actually, depending on what metric I'm looking at, the impact of that downtime can change. So at the P99, it's even more. It's 32 days. So what I'm seeing is that the risk is maybe is more prevalent at towards the tails. It's having more of an impact. So let's kind of go and have a little look at how these get created in a bit more detail. So first of all, what we do, we go to our probabilistic risk calendars tab, and we've got 4 different ways that we can actually create these types of weather or calendar risks. And of course, this weather downtime is the high wind speed is just kind of one possible example. Working in the UK, maybe it's excessive rainfall. There's too much rain, or if the ground freezes over, we can't do something, or the groundworks take longer. Or maybe if you're working in the Gulf, maybe it's excessive temperatures in the summer months, or sandstorms, or whatever it might be. And so what we're looking to do with these probabilistic risk calendars is really to kind of think about the risks where the probability changes over time, and it changes over time in a way which is based on probability. So what we're not looking to do with this is to capture things like, I don't know, the impact of Christmas holidays or Ramadan or Eid holidays or whatever it might be. We're really looking to capture the impact of risks where the probability it varies. So we're not using it for things where we know with any certainty that there's going to be an impact of an extra public holiday. We're looking to really just use this for modeling risk events which are uncertain, and where the uncertainty varies according to the time of year. So we've got 4 different ways that we can do this. We can generate from a time series, which we'll come back and look at the end. But we can also use some templates that Safran has got in order to really kind of build up these risk calendars really quickly and easily. So what I'm going to do, I'm just going to click generate from template, and I'm going to say I want to create a new calendar template. And the idea here is that I need to put in some various parameters, and then Safran will use those parameters to generate an entirely new calendar for me. And so what I've got, I'm going to, first of all, we're going to start with this one down here. You can see we've got these three different options. So you've got probability of downtime, a window of downtime, and blocks of downtime, which are all very confusingly named, or very similar names. Once you obviously understand how they work and you kind of play with Safran a little bit more, it's very easy to kind of to pick these up. But I'm always aware that all these names, they all seem a little bit interchangeable when you're first looking at it. But we're going to start off with this probability of downtime. And so up here, I'm going to give it a name, this calendar template. I'm going to call it prob downtime, and I'm going to just copy that. I'm going to paste it into the description as well. We don't need to kind of talk for a long time how to name things up, and I'm going to put this in a group, and I'm going to call this March. And the reason I'm going to put it in a group, we'll see in a minute, but you can kind of capture these calendars all in the same place. Now over here, I'm going to ask Safran to generate 1,000 samples, and we'll look at the significance of this number in a bit more detail shortly. But essentially, what happens is that whatever numbers we ask Safran to use for the samples, Safran will then build a database, almost like a library of samples that we then use when we're running a simulation. We'll kind of explore that in a bit more detail shortly. We put a start date and an end date, and what you'll see is that by default, when we create these up, Safran gives us a start date of today, and then an end date of today plus 10 years. And so obviously you could choose any number here or any date here that you wanted to. What we would always recommend is that however long your project is meant to be going on for, it's always a really good idea to make sure that that actually you add some time onto that, because of course as soon as we start running a quantitative schedule risk analysis, whatever the planner thought originally was our completion date, it's some more often than not moved around quite a bit. So we'd always recommend adding at least a few years on at the end of your samples, because otherwise what will happen is you're getting towards the end of your project. If you haven't remembered to update your calendar, but your project has now taken an extra few years, you might actually run out of samples. So it's always a good idea to make sure you kind of add at least a decent amount of cushioning on the end of it. So so what we're going to look at first then is this one down the bottom, this probability of downtime. So I'm going to click add period, and then you'll see that this extra row has appeared down at the bottom. I'm going to give this exactly the same name to keep things nice and easy, probability of downtime. And the first thing that we select here is which year of our project, or which years of our project do we want this to be applied to? So we can either do it the same for all years, or we could customize it on a year-by-year basis if we particularly wanted to. I'm just going to do all years for now, just to kind of keep things moving quickly and not make you all kind of watch me have to put in individual values for each of these. But I think the idea here is that because we live on a planet where the climate is changing relatively rapidly, we can probably now start to see almost measurable changes in terms of the weather on a year-by-year basis compared to maybe how it was not so long ago. And so we might even want to, if you really wanted to start getting into that kind of level of detail, you might take a view on things where instead of having a fixed rate of, say, I don't know, 10% probability of downtime for a particular period of time, maybe over time that's going to increase or it's going to decrease depending on what type of weather event you're observing or trying to model. But for now, I'm just going to use all years. And so what I'm setting up here is a calendar where, let's say for the month of January, between this period here, the 2025 and 2035, on any day in January, we've got an average chance of downtime of 10%. So if I then click, so once I've set this up, I will then go and generate the calendar. And this particular one, this probability of downtime, this is a calendar event, a calendar risk, where what we're saying is that on any day within the time period that we specify here, there is a 10% probability of downtime. And each of those each of those probabilities, each of those days are sampled independently. So there's no link between what happens on one day and what happens on the next day. So the chance of downtime lost to storms on a particular day in January. So once we click generate calendar, if we then close out, in fact, let me give this another name here. I'm going to call this one, I'm also going to give this a name of prob downtime as well. You'll see there's lots of places to give names for these things. I'm never quite sure exactly which name goes where, but I'm just going to give them all the same one just to keep it nice and easy. So if I then close this down and go and have a look in my March calendar, this March folder that I've just set up. Whereabouts are we? Okay, so what we can see is we've got the average probability of downtime in January 2026. And so what we can see is that on any given day, there's a chance of downtime. But if we look at it, if we kind of zoom out and look at the average, we can see that roughly there's about a 10% probability. But there's no link between these. So although we've got a 10% probability on any given day, when we actually then start to sample this, what we can then see is that sometimes we might have no days, like this sample here, 3 days, 6 days, 3 days, 3 days, 2 days, 1 day. So there's we can have any number, theoretically we could have any number of samples between 0 and 31, although in reality we'd have to have a much higher probability to get anywhere near 30 samples, because obviously 10% is not particularly high at all. But each of these samples is occurring independently of each other. And actually, if we go back to this all samples view, what we can see is that the numbers here, they're not kind of exactly 10%, but they're pretty close. Now, the reason they're not 10% is because of the way that Safran creates these calendars. Now, if we imagine just to kind of give a little bit of information about this, if we imagine that instead of a probability of 10%, let's imagine we had a probability of 50%. And the reason I'm saying 50% is because it's a nice easy one to understand, because we can talk about heads or tails. So we can flip a coin, and so heads we have downtime, tails we don't have downtime. So when we build up these templates and we ask Safran to generate 1,000 samples, what's actually happening from a technical perspective is that for each day within the period that we set up, Safran then generates or builds a distribution that then covers our sample. And so if, for example, that was 50%, it would be like for I don't know, on the 1st of January, it'd be like flipping a coin 1,000 times, because we're generating 1,000 samples. And so we've got 1,000 coins that we're flipping in the air, and we're calling heads or tails for each of those. And so what you would expect to see, the kind of from a theoretical perspective, if you flipped a coin 1,000 times, you would expect to see 500 heads and 500 tails. But of course, because we're flipping a coin, over time, we might expect to get some level of convergence around that. But actually, we don't know how many samples we might need to take to actually get to some level of convergence. And so, typically speaking, the lower the number of samples, the further away we are from that idea of convergence. Because what we're doing, when Safran is not just creating a probability in the cells, it's actually running some samples based on the probability that's been put in there. And the reason being is it makes the simulation time much faster when the actual simulation is running, to have this pre-built library of samples that can be used. But what it means is that if we build with a relatively low number of samples, for example, here I've got an example of this exact same one where we've got 100 samples, we can see that although there might be some which are 10, 11%, we've got one here that's 5%, another which is 14%, another that's 8%, another that's 11%. And so because we've only run 100 samples, we haven't kind of got to the point that we haven't really got particularly close to convergence. I did the same exercise with 1,000 samples, and you can see here there is still some variability, but they are much kind of closer together. or rather closer to 10%. And then when I ran it with 10,000 samples, you can see that pretty much all of these, in fact, all of them are exactly 10%. So for those of you who kind of have ever wondered why the numbers that you see here might be different from the numbers that you might expect, it's probably that you didn't run or build enough samples to begin with. And so again, it's because Safran, it creates a distribution for each of the dates, and then it runs a simulation using that distribution, and then it counts up the results, which is what we're seeing here. So so that's the kind of probability of downtime. So it's one where on any given day we've got a 10% chance of downtime, which means we could have anything from zero number of days downtime upwards. Now, the second type that we've got here, and of course the idea with this is that we can either kind of build up our calendars with some historic data, which is the time series, which we'll look at in a moment. But if we haven't got a decent amount of time series data, the idea here is that we've got these three different ways that we can build these up, depending on our understanding of what we think might happen. And we might just have a small amount of data, or we might have kind of looked at the last few years and taken a pragmatic view on things. And although we're very much looking to build our models that are as realistic as possible, we also want to make them pragmatic as well. So even if we haven't got a huge amount of data, as long as we can make a defensible choice about what we think the probability of downtime is, or how many blocks of downtime, we can use that we can use our kind of pragmatic view on things to still come up with something which is credible and quite realistic, which we'll come back and talk about a bit more in a little while. But let's now look at the second one, which is this window of downtime. And so I'm just going to create a new template for that, and I'm going to call it window here, and I'm going to call this one window. And again, I'm going to put that in my March group. And so for the window of downtime, the idea is that what we're looking to capture with this is where we have a single block of time where we don't know exactly when that's going to start, we don't know exactly when it's going to finish, or how long it's going to be, but it's a single block of time. So the example that Safran used is something like a canal freeze over, where every year maybe we have a canal that it freezes over. And when it freezes, we can't ship our goods down it. Our transportation kind of canal barges can't go down it. And so the earliest we've ever seen a canal freeze over is maybe the 1st of January. Most likely it's going to be, I don't know, the 3rd of January. And the very latest is maybe the 5th of January. And then at some point, the weather warms up again and that ice defrosts, and we can then start to ship our goods down it again. And maybe the earliest we've ever seen it defrost is maybe the 16th of January, most likely around about the 19th, and at the very latest, maybe the 25th of January. And so what Safran does with window downtime is it treats the start and end date as a 3-point estimate. And so if you imagine a triangle or PERT distribution where you have a start of the first on the first date, then most likely on the 3rd, and then the latest at the 5th, we're then building up a distribution as to an uncertainty around the start and an uncertainty around the end date. And so if I click generate calendar, and close this down and go back into March, we have a look at the window. Oops, what have I done? I've done something very, very strange. What have I done? I'm not exactly sure. This is very peculiar. Let me just double check my settings on that and make sure I didn't do anything particularly wrong. What was it? Window downtime. I don't know. I just got some very, very peculiar results. Let's have a little look, see if I've got another one here, rather than kind of trying to troubleshoot on the fly. That looks better. I'll go and investigate and try and figure out the cause of that in a little while. But essentially, this is exactly the same kind of example. Fortunately, for those of you who are kind of based in the UK and are familiar with Blue Peter, it's a kind of, here's one I prepared earlier. Fortunately, so what we've got then, we've got a calendar here here where we've got some uncertainty around the start date, we've got some uncertainty around the end date, and so that block of downtime itself is uncertain. So we're not sure exactly when the canal is going to freeze over. We're not exactly sure when it's going to kind of defrost again, and so the amount of downtime that is going to be applied for that is going to be uncertain as well. So this is the one which we would use if we had just a single block of time. So we might also use this for things like, I don't know, planned maintenance on a particular industrial unit, where every year we need to do some maintenance. We don't know exactly when we're going to need to do that. We're going to be led by, I don't know, our readings from the instrumentation control room or something, and we don't know exactly how long it's going to take us once we get in there, because until we see what the state of the unit is inside. And so what we're looking to do, we're looking to model this maintenance shutdown kind of turnaround time for this particular industrial unit, this one solid lump of time. So the third type of template we can use then is this one which we call the blocks of downtime. So again, I'm going to call this one blocks. There we go. Oh, I want to cut that out. Having all sorts of copy and paste fails. For some reason, the control button on my laptop has stopped working, which is really not very helpful for this sort of exercise. So the blocks of downtime, then, these are ones where we might have a number of bits of downtime over the course of the year. And so what we're going to do here, we're going to set up some downtime which maybe runs from the 1st of April through to the 1st of October. And so the number of blocks is how many occurrences of downtime do we think we're going to get over that time period. So here I'm going to say, let's say a minimum of 2 and a maximum of 9, and maybe with a most likely value of 4. And so the block size then is how long do each of those bits of downtime last. And so we've got a certain amount of downtime from the a certain number of occurrences, and let's say that these last, maybe it's some seasonal storms or something like that, and those storms are going to last at least 1 day, most likely 2 days, a maximum of 5 days. And so when I then click generate calendar for that one, and we're going to have a look at the results for that. We're going to have a look at the blocks and go across. What we can see is that between the months of April and September, what we're seeing is, between 2 and 9 blocks of downtime, and each of those blocks is lasting somewhere between 1 and 5 days. So those are the 3 options that we've got from the calendar templates. But the final thing is if we've actually got some time series data. Now, if we have some time series data, what we're able to do is to use Safran to populate kind of like a forward-facing model based on our historic data. And so if you've got a trial version of Safran or a full version of Safran already, you can actually kind of play with this yourselves, because if you click on the burger menu and then go to the log file folder up at the top, what that does, it opens up this application data, which is part of the Safran, where the Safran temporary data sits. And if we go into the risk folder here, and then into this sample data, this is where we can see all of the different example models that ship with Safran. And I've actually put mine in this time series folder up here. And so if I open this up, this is actually that wind speed example, and it was put together, I think, for Safran by this BMT Argos, which is a consultancy in the UK. It does a lot of stuff in the aerospace and defence, I think. And when we've got a time series, what Safran needs, it needs 2 bits of data for each kind of point, essentially. And so here what we've got is the time period, and so these are the observations of historical data. And so what we can see here is that every day we've got 8 observations, which means that what we're looking at is 3-hour periods here. So over the course of the day, we've got 3-hour chunks for observations. And so here what we've got is the actual parameter. We've got the meters per second. And then here what we've got is a 0 or 1. And the zero is so if our wind speed is less than 15 meters per second, which is, for example, this one here, 14 point, this is very, very precise, but 14.55 kind of rounded up is less than 15 meters per second. And so the zero means that the observation, it didn't happen. It didn't exceed the criteria that we've used, this 15 meters per second. Whereas this one here, 15.58, that's more than 15, so we've got a 1. In fact, all these ones here, it's higher than 1, and then we've got a few where it's lower than 1, and so on. And so all we have to do to get this into Safran, then we take the first bit of data, and then we scroll down to the bottom. You can see I've got a fair old amount of data in here, and then I'm going to select all of that. I'm going to right click, and then I'm going to go to copy, and then I'm going to go back into Safran. I'm going to go to the generate from time series window, and then here I've got a little option that says paste time series, and I paste that in, and then Safran has now kind of imported all that in, and it's up at the top. It's given me some various kind of observations about that data. So 29,216 observations, where actually the downtime was, there was a fairly significant amount of downtime over that period. We've got the earliest start date, the latest time, and so on, what the time span was, what the interval was between the items. So here, what we can do again, we can then just start to give things, a name, etc. for when we save it. Time series data. I'm going to put this in March as well. Now, down the bottom, we can then choose whether we want to have one kind of sample from all 10 years, or if we wanted to then generate kind of consecutive years of data to kind of use on an ongoing basis, we'd use this randomly selected years. And I'm going to just give it slightly less samples. I'm going to give it 500 because otherwise it'll take a little while to build it. And the seed is just going to be fixed as 0. So each time I run the model, I get exactly the same results for the same iteration. And so if I now go and generate the calendar, you can see my little spinning blue circle here, just while Safran is creating 500 samples for 10 years, 365 days a year, and each of those days got like eight possible samples because we're looking at 3 hours. So there's a fair old amount of data which Safran is essentially simulating and generating samples for. And you can see that now it's that blue circle's finished. If I go back in and have a look at my time series data, this is now the data that I've got based on the time series that Safran has just imported. So we've now got that the time series historic data that we're capturing here. So what I would say about the time series data is that you need to have a decent amount of it for it to work well. If you've just got 1 or 2 years, that's not really enough for Safran to kind of create any meaningful samples from it. And so I think from kind of various testing that I've done, between kind of maybe 5 and 7 years at least is a reasonable amount of data. And as I said before, if you don't have that much data, if you don't actually have a huge amount of historical data, you could still look in put your data in Excel and count to see how many storms you've had in the last couple of years, 2 or 3 years, and how long those storms lasted. And you can do that sort of thing pretty easily in Excel, and then you could just use the templates to build those up in a fairly simple way. Which one was it? That was my blocked one there. So if you don't need to have lots and lots and lots and lots of historical data, but you just need to be able to make a reasoned or informed choice as to how many what your downtime has looked like over that, and in order to get it into Safran. So I think that's probably about it. Oh, the one other thing that you can do if you wanted to, well, 2 other things really. So first of all, you can put in your long lat codes, and so if you wanted to kind of show on a map exactly where you are, you could do this here. I did actually look at mine earlier on today, and I managed to forget what the numbers were, but essentially what you can do wherever you are, you can use these long lat codes to kind of to capture exactly whereabouts you are, just so it kind of displays on the map. Again, it doesn't this serves absolutely no purpose other than for it to be a visual cue of exactly where you're looking at, because actually what's quite common then when people use this is that they might want to then start sharing these things around. You have one person building this up within an organization, and then it gets shared across other people. And so once we've created these calendars, we can just do an export of them. So we've got the ability to export calendar samples. And so if I was to click export calendar samples, I'm going to call this downtime blocks and save, then the information that I've built up in my Safran model, I could then share it with someone else, share the file with them, and then at the other end they could go and import that file, and then they could use those same samples. So it's a really kind of good thing to be using if you're working on a big kind of program of work or project where you've got lots and lots of people working on the same model, where you might have lots of supply chain contractors all working on the same kind of project, and you want everyone to have a shared view on the calendar risks. The other thing as well that you can do with Safran is that with Safran's kind of global risk area, when everyone's working on a shared database using Safran, you have the ability to set up these shared risks where everyone in the organization or everyone working on a particular project or business line or whatever it might be is able to see exactly the same global risks. And so what I could do, I could go and create a new global risk, and I could call this one my risk calendar over here, and call it probabilistic. I'm hoping I spelled the word probabilistic correctly. I've been working in the field long enough that you would expect so, but sometimes I fail on it. But if I change that to a calendar risk, I could then go and select one of my calendars that I've been built up, and then I can use this as in my global risks. And then when someone joins the project or starts working on the project, rather than then having to go and kind of create it from scratch, they could just go to the project risk tab, and then they can go and import that risk calendar, and then to be able to then start using that on projects going forward. So there's some quite nice stuff that you can do from a sharing perspective, but hopefully at least that's given some ideas as to exactly how we can use these probabilistic calendars within Safran. Apologies, there's a few little kind of hiccups along the way, but does anybody have any questions? Okay, right. So I'm just reading one here. So it says the risk of bad weather is only quantified as an impact on the schedule, but generally there will also be an impact on the project cost. Is there a way to integrate the cost impact caused by bad weather? Now that's a really interesting and really good question. So thank you very much for that. And let's kind of just highlight exactly what that means a little bit. So fortunately, I've got a model that shows exactly that thing. So if we kind of go and have a little look back at this sensitivity analysis, where what we could see that we had this calendar risk, which has got potentially having 32 days of impact on our schedule. But actually, within my cost model here, what we can see is that, so now what we're looking at is the kind of the cost and time impact of the risks from our risk register. And so from a schedule perspective, this weather downtime risk is 32 days. That's my biggest risk. But from a cost perspective, actually, I've got this parts supply risk is a far bigger concern. And so what we're seeing here is when we've got a shared risk register as we have in Safran, we've got the ability to have risks which could be to do with cost as well as schedule. And what the question was that we can have something which has got a big kind of calendar impact as a result of some calendar risk, but actually all we're doing with that is impacting the schedule. So the way we'd need to do that, the way in which we probably need to model that, there's two ways that we can kind of really look at this. So if we were working with a cost or resource loaded schedule, then we would naturally expect the cost impact of this to be felt by the fact that we've got our cost and resources against the schedule. So if the activity takes longer, it's going to cost us more. Now, sometimes it's not quite as straightforward as that. Sometimes there might be a mix of kind of fixed and variable costs. It might be that we're not necessarily needing to pay for all of the delay, but we might pay for some of the delay. And so how do we go about capturing that within Safran? And so the answer to that would probably be to do something within the cost module over here, where what we could probably do is to build up some kind of a link between the activity and something in the cost model. So for example, down here in this PMO cost down the bottom, I've got something where I've linked an item in my cost model to an item in the schedule. And so what that means is that when a particular item in the schedule takes a longer period of time, for example, this PMO hammock down here, in the deterministic world, it's 117 days. And so in my deterministic kind of world, that it's going to cost me 3.5 million for that particular activity based on that 117 days. But actually, when I then start to run a simulation, that activity, as you can see, is no longer 117 days. That the duration for it changes. And so within the cost module for Safran, we could reflect that change such that if the activity is taking longer, then it's going to cost us more. So building in some kind of a link between the activity and the cost is probably a good way to do it. It's a kind of good pragmatic choice. We could even build up some kind of a conditional scripting model using the kind of the JavaScript one, which even I have got hidden from my view up here, where we've got the ability to go and set up this kind of like this JavaScript type approach where we could build in some conditional logic there. So there's probably a few different ways in which we could do it, I think.